All right, so if you're interested, and if we were all back together, we would be talking about this. Like, why does this L'Hopital's rule work for like 0/0? And it kind of goes back to something we learned when we were first together that we used all year long. So if you want to do the limit as x approaches some constant of f of x over g of x. Okay, we learned, it's like the most important thing, that if the function f and g are differentiable, so they're nice, if they behave nicely around c, we can say not everywhere, but around c, function f really looks like the tangent line. Remember we very first started with that? So around x equals c, we're going to model f with its tangent line at c. Okay, so let's see. So we would have y minus f of c would be worth, bye-bye, that's my daughter leaving, and the slope, which is f prime of c, x minus the x number, which is c. So and if we move all the terms over, we would move this over here. So the function f would be about equal to, not everywhere, but just at c, f of c plus f prime of c and x minus c. Okay? And if you did g, it would be the same thing. So as long as these functions are nicely behaved, this is going to be true. So this would be g of c plus g prime of c times x minus c. So we're essentially saying, because mathematicians are problem solvers, let's model this ratio just where we're looking with the tangent lines. All right, now here's why you can only do it for two forms. Okay, the first form is 0/0. So if this form was 0/0 at c, this number is 0, and this number is 0, which means all this part goes away, and this is the same. So that means that the limit as x approaches c would just have to be f prime of c over g prime of c, provided that g prime is not 0. So you just get these two things. Now my math's not as careful as it should be, but that's the general idea. And then if you're really, really clever, say it was infinity over infinity, and that was like f over g. You can be super clever, and instead of f over g is the same thing as 1 over g times 1 over f. But this is like 1 over infinity, and this is like 1 over infinity. So now you've got a 0/0 form, so L'Hopital's applies. Cool beans. Let's just shout out to Miss Heinemann.